I'm Dr. Molly Miller, and I'm going to give an update on the Pennsylvania Science and Technology and Environment and Ecology Standards Revision. So, this entire work started back in September of 2019 when PD began the process of updating Pennsylvania science standards. And as such, we've seen a lot of press and announcements come out that these are an update of the science standards. But it's important to note that in Pennsylvania, those science standards also include our technology and engineering standards, as well as environment and ecology standards. The goal of the work was to collaboratively look over evidence-based practices, research, data, in order to develop a set of recommendations back to the State Board of Ed. I cannot stress enough how much data really was a consideration in this. So the process began way back in February and March with stakeholder meetings. Many of you were active at those meetings, and all of those meetings led to a really rich set of data that was considered by everyone on the writing teams. So when the process moved forward out of stakeholder meetings, there was an application process to be on the content or steering committees. So um, I was on part of the content committee, so I can speak a bit more as to what they did, but it really was a back and forth process over the summer between, we had 6 full day meetings for the content committee that were held virtually, and then there were 2.5 or 3 meetings for the steering committee. So the content committee would meet for 2 days to look at data points to kind of start to get guiding principles and documents ready, and those would go to the steering committee who would give us feedback and who would look over our work and kind of put stress where they felt it needed to go. That went back and forth for about 3 or 4 weeks before it moved forward along that process. The guiding focus throughout all of this has been that there needs to be Pennsylvania context. So Pennsylvania is not a state that usually just adopts standards as is. We want to see how it relates specifically to the students in this state. Pennsylvania is really strong in agriculture and environment, and the economy and business in Pennsylvania kind of mirrors that. So it was very important to have that PA context within the standards. It was also important across the board to emphasize things like design thinking, habits of mind, and practices in all content areas, and really kind of focus on the way that the standards should have students act rather than just a list of things that they should know. There were some main principles that we considered throughout development. One was that we wanted to make sure they were transparent. We wanted to make sure the standards were inclusive, that they focused on equity for all students, that they were research informed, that they were consistent across the board, that they were substantive, right? They weren't just something that we were going to put out there to say we had new standards, but there were some meat on those bones. And also that they were improvement oriented. Some major decisions that were made along the way. This came out of the stages where we were still the content and the steering committee going back and forth. One was grade banding and how that would work. So this decision was made in 2 parts. Grades K through 5, what you'll see in the standards recommendation are that K to 5 are separated into individual grades K, 1, 2, 3, 4, and 5 for standards and content. We just felt that that was going to be clearest. It was going to make more sense for elementary teachers and students. And then grades 6 through 12, we made the decision that they would be banded. So there would be a grade 6 through 8 band and a grade 9 through 12 band for standards and content. Another big decision that was made between the content and the steering committee stage of development was that we would be creating 3 separate documents. So the first document would be K to 5, and that would be integrated standards. So that would include science, environment, ecology, technology, and engineering broken down into individual grades. The other 2 documents that are part of this standards revision are a 6 through 12 science, environment, and ecology standards document and a grade 6 through 12 technology and engineering standards document. I can't even count how many different polls and discussions we had on whether these should all be one document, separate documents, what should this look like, who should be grouped together. but I can speak for, I think, all of the technology and engineering teachers that were on that steering or content committee, that we were pretty happy with the result of having our own set of standards back in the state, and not kind of getting lost in the shuffle of science, environment, and ecology. From that point, um, we were kind of asked as a content committee who would be interested in serving on a team to start kind of fleshing out what these standards would look like and kind of writing these standards. So a team of about 6 or 7 of us were um, volunteered throughout the state, and Mike Oldrich and myself were chosen to kind of lead these efforts for grades 6 through 12 technology and engineering standards. So that's what I'm going to focus in on. At the end, I'll show you how to access all 3 standards documents, but these are the ones we're going to look at most closely. So the new recommendation for 6 through 12 technology and engineering standards kind of come in 4 parts. So the first part is core disciplinary standards. Then there are technology and engineering practices. There are PA career ready skills, and there are contexts. And we'll look at those a little bit more closely right now. So the first are technology and engineering core disciplinary standards. And when we first started thinking about what should these standards look like, and we were kind of considering a whole lot of areas, we started to look at what are already excellent technology and engineering standards. And the timing is just perfect to do this in Pennsylvania because ITEEA just put out a really great document in their standards for technological and engineering literacy, and they had a whole lot of research and a whole lot of really bright minds come together to create those standards. So early on, the technology and engineering people on that team decided that the STEL document is what we were going to use as a basis. But that doesn't mean that we were going to adopt it wholeheartedly just as is. So we made quite a few changes. We had a lot of discussion about the STEL document, its strengths, its weaknesses, and how we could make it fit better for Pennsylvania. So what you will see in the recommendation document is that there are 4 core disciplinary standards. There is the nature and characteristics of technology and engineering. And if you're familiar with the STEL document, that kind of encompasses the nature and characteristics category, the core concepts category, and the history. There will be an integration of knowledge, technologies, and practices. There will be a core disciplinary standard of applying, maintaining, assessing, and evaluating technological products and systems. And again, if you're familiar with STEL, that is the applying, maintaining, and assessing, the impacts, the influence of, and the society and environmental impacts of technology and engineering education. And then the fourth core disciplinary standard is design thinking in technology and engineering education. Technology and engineering practices, we kind of thought of as the behaviors that you would see students actively doing in the classroom if you were to take a peek into a technology and engineering classroom in Pennsylvania. So we chose 6 practices, and they are making and doing, safety, systems thinking, optimization, integrating concepts, and problem solving. And we really tried to think about what are the non-negotiables of technology and engineering education. And they're really these things, right? We wouldn't be here in the field of technology and engineering or trying to promote the field of technology and engineering education without the making and doing hands-on component of the classroom. So that was really important, as well as making sure that safety was going to be considered across the board. The next category was technology and engineering career ready skills. So these are kind of the habits of mind, the soft skills, the 21st century skills, whatever you want to call them or whatever you're familiar with. The 6 that were chosen for the recommendation document were creativity, persistence, collaboration, communication, conscientiousness, and empathy. We thought those were really the skills that we wanted to develop in students and the skills that fit most closely with technology and engineering education. Finally, we have the technology and engineering contexts, and these are what you might kind of think about when you think about the courses or the activities within technology and engineering. All standards don't need to be based in what the class is or what the title of the course is, because a lot of the same types of information can be covered across these contexts. So the 7 contexts that the writing team kind of debated and decided on were computation, automation, artificial intelligence, and robotics, material conversion and processing, transportation and logistics, energy and power, information and communication, the built environment, and bio-related technologies. So again, that's very similar to the STEL document. There was one kind of collaboration where bio-related technologies became the header for two different categories of the STEL, but that was mainly just based on the fact that we felt it made more sense that way, and it was a little bit arbitrary in how the STEL document separated out some of their contexts. So how do these four pieces fit together into what you'll see in the standards document, which we'll get to? This is an example of a standard. So the standard that we're looking at is Design Thinking in Technology and Engineering Education. And the benchmark for that standard, 4HF, tells us it is a high school standard, so it's grades 9 through 12. And the benchmark is to implement the best possible solution to a design using an explicit process. We tried to keep it open and really ready to interpret for teachers. So an explicit process doesn't say that you need to be using the design thinking process or the engineering design process or possibly the scientific method. It just says that students need to be able to implement the best solution to a design while still using a process. There's a descriptor that gives a little bit more explanation to what that benchmark looks like. You'll see key practices. So we looked at all of the practices and all of the PA Career Ready skills, but each standard will have two or three that are pulled out that really tie in closely to that standard and benchmark. You'll have PA connections. So we really tried to think about what does this look like in Pennsylvania. So here you can see they're talking about Tate Towers, which is in Lidditz, PA, and talking about kind of what they do there and how it plays a role in this benchmark. What you'll also see with each and every standard are connections to other content areas. So we pulled out math, we pulled out science and environment and ecology, we pulled out English language arts. But there are also other standards that will be pulled from time to time based on that benchmark. But this is the new format for what a standard will really look like. There'll be a standard and a benchmark, followed by a whole lot of other kind of supporting information, including those practices and skills. So the way that this should actually look, right? We've talked a little bit about the parts of it, but they should all fit together to make a cohesive learning experience for students. So here's an exemplar right out of the standards document. Students can apply standard benchmark 4HM, safely apply an appropriate range of making skills to a design thinking process in the context of biorelated technologies by designing and making a device that will safely capture an invasive pest. So one example specific to PA is the spotted lanternfly. And the spotted lanternfly is actually native to China, but it was first spotted in Pennsylvania in Berks County back in 2014. It feels like we've only been dealing with them more recently, but that was their first spotting in the state. And it feeds on plants that are important to Pennsylvania's economy, and it's increasingly caused a lot of damage in our state. Students can utilize the technology and engineering practice of making and doing to study the spotted lanternfly and safely use appropriate materials and processes to build a device to catch the invasive pest. This addresses the technology and engineering PA career ready skill of creativity. So see how these four parts, the core disciplinary standard and benchmark, the context, the PA Career Ready skill, and the practice all work together to create a cohesive kind of experience for our students. So what's the current state of this work? It was presented to the state board in September for their review and approval, and now they're posted online ready to be viewed. So I created just a tiny URL. You can also get all of the documents from the PA Department of Ed website, but the tiny URLs are just tinyurl.com/ either PA K5 integrated for those standards, PA 612 TE for our technology and engineering standards, or PA 612 Sci-EE for the science, environment, and ecology standards. They're almost ready for public comment and feedback, and you should be looking for that to come really shortly. But I would encourage you to really dig deep into them. The process is not over. The next step is to go back to our stakeholders and get that feedback. Are they clear? Are they concise? Did we meet a lot of those goals that we started with? So what we need you to do right now is get your voice ready. Look through that document, form your opinion, be informed about what's coming, and keep an eye out for that public comment period, which will be coming soon. If you're a TEEP member, I promise you will be notified when that time comes, just like you were when the stakeholder meetings were happening and when the time came to kind of apply to be part of this process. Get your voice ready. This is a great opportunity to really make a difference in what takes place in your classroom, in other classrooms, in your children's classroom. So look over those documents and be ready when the time comes for that public comment period. If you have any questions or concerns, please reach out to me. My email is on the TEEP website, but you can also email me at molly.miller@penmanor.net. You can reach out if you know someone else on the writing team. Reach out to Brant Hutzel, our technology and engineering kind of advisor for the state. I encourage you to get involved, be informed, and be ready when the time comes to state your opinion. Thank you.